Okay, so let's use the lookup table to find a few probabilities of the standard normal random variable. So let's look first at this problem. What's the probability that z is less than 1.32? Okay, so let's first visualize what this looks like. Okay, this is random variable z. It has a mean of 0 and a standard deviation of 1. Okay, we know that. And we are going to look for 1.32 standard deviations away. Okay, so whenever we convert that y value to a z value using the z-score, we're measuring how far away in standard deviations is that y value. And let's just say it's 1.32. And we want to know what's the probability that z is less than 1.32. Okay, what's the probability that we get a realization of z that's less than 1.32? Okay, so we need to find this area using our lookup table. Well, if we use this area, if we use the lookup table is going to give us this. Here's 1.32, here's 0, okay? We're going to have this area from the lookup table, okay? So we're going to go down to the 1.3 row, down to 1.3, and over to the 0.02 column, and that intersection is going to give us this area. Okay, that's how we read the lookup table. Down to 1.3, over to 0.02, that intersection is this area between 0 and the value z that we're looking up. As it turns out, if you use the lookup table, you'll find that this area is 0.4066. Okay, so the area between 0 and 1.32 is 0.4066. But that's not what we want here, okay? That's just this area right here. We want all of this area. Well, we said that the z distribution is a symmetric distribution. That must mean that above 0 lies half of the probability, and below 0 lies half of the probability. So the probability from 0 up to positive infinity is 0.5. The probability from 0 down to negative infinity is also 0.5. So that must mean that this area right here is 0.5. Okay? So what's the probability then that z is less than 1.32? It is 0.4066, this area, plus all this area, plus 0.5. And that is 0.9066. The probability that z takes on a value less than 1.32, 0.9066. Okay, let's take a look at another example. Let's say we wanted to know what's the probability that z is less than a value 3. Okay? What's the probability that z takes on a realization that's less than 3? Mean is 0, standard deviation is 1. Okay? And we want this area. Probability that z is less than 3. Okay? Well, this lookup table is going to give us this area. Okay? What's the probability that the value of z lies between 0 and 3? So we go down to the row associated with 3.0, over to the column associated with 0.00. That intersection is going to be this area between 0 and 3. And that area, that area is 0.4987. Okay? So the probability that z is between 0 and 3, 0.4987. And the probability that z is less than 0, 0.5. So to find that area, that is 0.4987 plus 0.5, which is 0.9987. Okay? Another way to say that is 99.87% of observations of z lie below 3. Okay, let's do another one. Here's our z distribution. And let's say that we wanted, what's the probability that z is greater than 1.45? Okay, what's the probability that z takes on a realization greater than 1.45? Well, here's the mean 0 on this z distribution, on the z-axis. And we want the probability that z is greater than 1.45. That's this area right up here. Okay? If we go to our z lookup table, we're going to find this area. Okay? Because the lookup table that we're providing is between 0 and 1.45. Okay? That's the area that it provides. And if we go look up row 1.4 over to column 0.05, we're going to find the value 0.4265. 0.4265 is that area in between 0 and 1.45. But that's not the area we want. We want the upper tail value, the area above that. Okay? Well, we know that the area between 0 and positive infinity is 0.5. So that must mean if we take 0.5, subtract off this area right here, we'll be left with this. Okay? So we're going to take 0.5, the area above 0. We're going to subtract off the area between 0 and 1.45. That's this probability here, 0.4265. And that's going to leave us this tail area. Okay, if we do that, we should get 0.0735. So the probability that z is greater than 1.45, 0.035, 0.0735. Okay, roughly 7% of observations lie above 1.45.